Every submarine the United States Navy has put to sea in more than a century traces back to one company. Not most. Almost all of them. By the numbers, Electric Boat looks less like a shipbuilder and more like a monopoly. The government never had to build a single company so essential to undersea warfare that losing it would mean losing the ability to build submarines at all. But the paper trail tells a different story. Twice in its history, Electric Boat came close enough to insolvency that its survival was not a matter of strategy. It was a matter of timing. Save by wars it did not start, and by contracts that arrived just before the workforce disappeared for good between those rescues. Mass layoffs, idle machine shops, and years where the most specialized submarine building workforce on Earth had nothing to build. This is not the story of a company that mastered submarine construction and never looked back. It is the story of a company that nearly lost the ability to build submarines, more than once, and left the United States Navy dependent on the survival of a business that kept almost going under. The company is still building submarines today. That is not proof the system worked. It is proof of how many times it almost didn't. For most of the 20th century, the assumption inside the U.S. defense industrial base held that a company this critical to national security could not be allowed to fail, and therefore, in the public imagination, never came close to it. Electric Boat, the thinking went, occupied a permanent seat at the center of American undersea warfare. It built the first submarine the Navy ever commissioned. It built the nuclear-powered vessels that reshaped Cold War deterrence. By the time the Virginia-class entered service, the company's name had become nearly synonymous with the American submarine itself, the assumed, uncontested, permanent builder of the fleet. That assumption was wrong. The historical record shows a company that survived not on steady peacetime demand but on the erratic boom-and-bust rhythm of American war planning. Between major conflicts, submarine orders did not merely slow, they collapsed. Skilled labor forces built up over years were dismissed in months. Machine shops engineered for one purpose, and one purpose only, sat idle with no conventional commercial use to fall back on. Twice, that collapse pushed the company to the edge of extinction. Twice, it was pulled back, not by sound peacetime management, but by the sudden wartime return of the very demand that had vanished years earlier. Electric Boat did not endure because it solved the problem of boom-and-bust submarine procurement. It endured because, so far, the bust never lasted quite long enough to finish the job. That is the company this story is actually about. Electric Boat was incorporated in 1899. The creation of a New York patent attorney and businessman named Isaac Rice, who saw commercial promise in a technology the U.S. Navy had barely begun to take seriously. The design itself belonged to John Philip Holland, an Irish-born engineer who had spent nearly 3 decades trying to convince a skeptical American military establishment that a vessel capable of diving beneath the surface could be more than a novelty. His company, the Holland Torpedo Boat Company, held the patents. Rice's new venture absorbed it, and with it, absorbed Holland's design, and Holland's decades of frustration with a Navy that did not yet know what to do with a submersible warship. In April 1900, the Navy commissioned USS Holland, designated SS-1, the first submarine in the history of the United States Navy. It was a small vessel by any later standard, gasoline-powered on the surface, electric-powered when submerged, armed with a single torpedo tube. But it was real, it was commissioned, and it was built by Electric Boat. The commission did not trigger a rush of orders. The Navy's senior leadership remained divided on whether submarines represented a genuine addition to the fleet, or an expensive experiment better suited to coastal defense than open-water warfare. Surface admirals, trained in the doctrine of the battle line, saw little reason to redirect scarce shipbuilding budgets toward an unproven and, in the eyes of many, faintly disreputable class of vessel. Orders came but slowly. A handful of boats a year, sold as much to foreign navies as to the U.S. Navy itself. Electric Boat survived this first decade and a half not on the strength of a confident American submarine program, but on a scattered international customer base. Britain, Japan, Russia, and others willing to buy the design before Washington fully committed to it. By 1914, Electric Boat had proven the submarine could be built reliably and sold internationally. What it had not yet secured was the one thing that would determine its survival for the next 100 years. A U.S. Navy prepared to order submarines in wartime quantities, rather than peacetime trickles. That would take a war to change. The war that changed electric boats' fortunes began in Europe in 1914, and by the time the United States entered it in April 1917, the calculus around submarine warfare had shifted entirely. German U-boats had demonstrated, in brutal terms, exactly what a submerged vessel with torpedoes could do to merchant shipping and naval assets alike. The Navy that had spent 15 years treating submarines as a marginal experiment now needed them in numbers it had never before contemplated. Orders poured into Electric Boat's yard at Groton, Connecticut. The company that had built a handful of boats a year for foreign navies now found itself managing a construction program on a wartime scale, expanding its workforce, its physical plant, and its subcontracting network to meet a demand that had materialized in almost overnight. Thousands of workers were hired. Production lines that had built submarines essentially by hand were reorganized for volume. For the first time in its history, Electric Boat looked less like a niche patent holder and more like a genuine industrial power, a company whose name was now inseparable from the United States Navy's undersea fleet. The armistice in November 1918 ended that arrangement almost as quickly as it had begun. With the war over, the Navy's wartime submarine orders did not taper. They stopped. Congress, facing pressure to demobilize and cut wartime spending, saw little reason to sustain a submarine construction program built for a war that no longer existed. The workforce Electric Boat had spent 4 years building was dismissed in a fraction of that time. Machine tools configured for submarine hulls sat without contracts to fill them. The physical infrastructure remained, but the demand that justified it had vanished. This was the first time Electric Boat experienced in full the pattern that would define its next century, a surge of wartime demand followed by a peacetime collapse severe enough to threaten the company's survival. It would not be the last. By the early 1920s, Electric Boat was no longer the emergency scale builder it had been just a few years earlier. It was a company searching for enough work to justify keeping its doors open. The first real preview of the crisis still to come. The 1920s did not offer Electric Boat a recovery. They offered a slow, grinding confirmation that the wartime boom had been the exception, not the new baseline. With the U.S. Navy's post-war submarine program reduced to a trickle of orders, and Congress showing little appetite for expanding a fleet at a moment when the dominant political mood favored disarmament, Electric Boat's Groton yard operated at a fraction of its wartime capacity. The Washington Naval Treaty of 1922, aimed primarily at capital ships, nonetheless reinforced the broader climate. Naval expansion was politically unpopular, and submarines, still viewed by much of the surface navy as a secondary weapon, were an easy line item to cut. The specialized workforce built up during the war, welders, machinists, and engineers trained specifically for submarine construction, had nowhere else to go. Submarine hulls required skills that did not transfer cleanly to commercial shipbuilding, and commercial shipbuilding itself was hardly thriving. Electric Boat's leadership faced a problem with no easy solution, a workforce and a physical plant built for one narrow purpose. At a moment when that purpose had almost no customers, the company survived this period not through a strong submarine business, but by diversifying away from submarines almost entirely. Electric Boat took on contracts for small craft, engines, and other marine equipment that had little to do with the vessel that had made its name. It was, in effect, a submarine builder trying to stay solvent by not building submarines, a strategy that kept the lights on but did nothing to resolve the underlying vulnerability. By the early 1930s, the Great Depression compounded an already difficult decade. Capital was scarce, government contracts scarcer, and the international customer base that had once supplemented thin domestic orders had largely dried up as other nations built their own indigenous submarine industries. Rather than continuing to buy American-designed boats, Electric Boat did not formally collapse during these years, but it came close enough that its survival depended on the same pattern that had rescued it once already, the return of large-scale wartime demand. By the mid to late 1930s, as tensions in Europe and the Pacific began to escalate, and the U.S. Navy slowly resumed submarine construction in anticipation of a conflict few in Washington wanted to name outright. Electric Boat found itself, once again, on the edge of a demand surge it had not caused and could not control. The company that had nearly disappeared in peacetime was about to be needed more urgently than at any point in its history. The attack on Pearl Harbor, on December 7, 1941, ended 2 decades of uncertainty for Electric Boat in a single morning. The United States Navy, faced with the destruction or damage of much of its Pacific battle line, turned to its submarine force as one of the few weapons immediately capable of taking the fight to Japan. Electric Boat, the company that had spent the interwar years scraping by on small marine contracts, was about to become the center of the largest submarine construction effort in American history. The scale of the wartime buildup dwarfed even the surge of the First World War. Electric Boat's Groton Yard expanded its workforce dramatically, running multiple shifts around the clock. To meet demand the company could not fill alone. Electric Boat licensed its submarine designs to other shipyards, most significantly Manitowoc Shipbuilding in Wisconsin, a company with no prior submarine experience that nonetheless built dozens of boats to Electric Boat's plans, launching them sideways into the Manitowoc River and floating them down the Mississippi to reach salt water. It was an arrangement almost unthinkable a decade earlier, when Electric Boat had struggled to find enough work to keep its own yard running. By the war's end in 1945, American submarines built substantially to Electric Boat designs had sunk more Japanese shipping tonnage than any other branch of the U.S. military, a campaign that crippled Japan's ability to supply its home islands and its forces across the Pacific. Electric Boat had gone from a company fighting for survival to the industrial backbone of a submarine force that had helped decide the outcome of the war in the Pacific. But the pattern that had defined the company since 1918 had not been broken. It had simply been delayed. As VJ Day arrived in August 1945, the same question that had gutted Electric Boat after the First World War returned in force. What happens to a submarine building workforce and a submarine building yard once the war that justified them is over? Contracts began canceling within weeks. The Navy, facing a fleet larger than it needed for a peacetime footing, and a public eager for demobilization, had no intention of sustaining wartime-scale submarine orders into an uncertain peace. Electric Boat now stood at the edge of the exact cliff it had gone over once before. Except this time, unlike 1918, something else was coming that no one in Groton could yet see clearly. The next rescue would not simply be another war. It would be an entirely new kind of submarine, one that would change what Electric Boat was for good. The post-war contraction that followed 1945 unfolded almost exactly as it had after 1918. The Navy's wartime submarine orders evaporated. Electric Boat's workforce shrank sharply, and the company once again faced the question of what a submarine building yard was supposed to do when no one wanted submarines built. This time, the company's response was structural rather than merely operational. In 1952, Electric Boat merged into a new holding company, General Dynamics Corporation, a transaction that folded the century-old submarine builder into a larger diversified defense conglomerate. The merger did not by itself solve the underlying demand problem. What it did was position Electric Boat, now a division rather than an independent company, inside a corporate structure large enough to absorb lean years in a way the standalone Electric Boat of the 1920s never could. The timing proved decisive. Just 2 years after the merger, Electric Boat launched USS Nautilus on January 24, 1954, the world's first nuclear-powered submarine. Nautilus was not simply a new class of vessel. It was a fundamental redefinition of what a submarine could be. A ship no longer bound by the need to surface for air, capable of remaining submerged for weeks rather than hours. Powered by a reactor rather than diesel engines and batteries. The technical achievement belonged to a partnership between Electric Boat's engineering and construction expertise and the relentless program management of Admiral Hyman G. Rickover, whose insistence on nuclear propulsion had forced the Navy's hand years earlier. Nautilus proved the concept was not merely theoretical. It steamed under polar ice, crossed the Atlantic submerged, and demonstrated capabilities no diesel-electric submarine could match. For Electric Boat, Nautilus represented something the company had never fully possessed before, a genuine, durable reason for the U.S. Navy to keep ordering submarines even in peacetime. Nuclear propulsion was not a wartime emergency measure to be canceled. Once a conflict ended, it was a permanent strategic capability the Cold War Navy intended to build around indefinitely. But a durable reason to order submarines was not the same thing as a guaranteed stable order book. The Cold War would deliver Electric Boat its largest and most sustained submarine construction program in company history, and alongside it, a new kind of institutional conflict the company had never faced at this scale before. Disputes over cost, schedule, and control that would strain its relationship with the Navy for decades to come. The decades that followed, Nautilus delivered Electric Boat the closest thing to sustained peacetime demand the company had ever known. Nuclear propulsion transformed the submarine from a wartime contingency into a standing element of Cold War deterrence. And the Navy's appetite for new boats reflected that shift. Electric Boat built attack submarines, and beginning with the George Washington class in 1959, the ballistic missile submarines that would carry Polaris missiles beneath the ocean's surface, a role so strategically central that the boats themselves became a pillar of American nuclear deterrence, operating on continuous patrol cycles designed to guarantee a survivable second strike capability. Production numbers reflected the shift in scale. Where the interwar years had seen Electric Boats scrape by on a handful of contracts, the 1960s and 1970s saw the company building submarines in numbers that would have been unimaginable to its 1920s leadership, a construction tempo sustained not by a single war, but by an ongoing strategic competition with the Soviet Union that showed no sign of a clean end date. That scale came with a new kind of problem. As submarine designs grew more complex, deeper diving depths, quieter propulsion, more sophisticated sonar, and weapon systems, the cost and schedule discipline that had governed simpler diesel-electric construction began to break down. The Los Angeles-class attack submarines, the backbone of the Navy's Cold War attack fleet, experienced significant cost growth and the schedule delays during their construction runs through the 1970s and 1980s, straining Electric Boat's relationship with Navy contracting officials who were simultaneously trying to manage a large multi-decade shipbuilding program on a fixed and politically contested budget. The tension was not simply a matter of Electric Boat underperforming or the Navy demanding the impossible. It reflected a structural mismatch. Submarine construction on this scale required Electric Boat to commit enormous capital and labor to programs planned years in advance, while Navy funding remained subject to annual congressional appropriations. Shifting strategic priorities, and the inherent uncertainty of forecasting technology and threat over a submarine's decades-long service life. When costs rose faster than budgeted, both sides had reason to blame the other, and both had legitimate grievances. Nowhere would this tension surface more dramatically than in the program that followed the Los Angeles class. A submarine designed to be the most advanced undersea weapon the world had ever seen, and one whose cost overruns would become a defining crisis of Electric Boat's Cold War-era relationship with the U.S. Navy. That program was the Seawolf class, conceived in the 1980s as the answer to increasingly capable Soviet submarines, faster, deeper diving, and quieter than anything the U.S. Navy had put to sea before. Electric Boat began construction on the lead boat, USS Seawolf, in 1989, with the Navy's original plan calling for a class of roughly 30 submarines that would have anchored the American attack submarine fleet well into the 21st century. The Cold War ended before that plan could be carried out. With the Soviet Union's collapse in 1991, the strategic rationale that had justified a 30-boat Seawolf fleet largely disappeared within the span of a few years, and Congress moved to cancel the bulk of the program. What had been designed as a large, cost-amortized production run was truncated to just 3 submarines: Seawolf, Connecticut, and Jimmy Carter, a fraction of the original order that left the per-unit cost of each boat dramatically higher than planned, since the enormous fixed engineering and tooling costs of the program now had to be spread across 3 hulls instead of 30. The result was a program remembered less for its technical achievement, which was genuine, than for its cost. Each Seawolf-class submarine ultimately cost well over $2 billion, figures that drew sustained scrutiny from Congress, and reinforced, in the eyes of Navy budget planners, a growing skepticism about the sustainability of Electric Boat's cost structure on high-end submarine programs. For Electric Boat, the Seawolf cancellation delivered a blow that echoed the company's earlier post-war collapses, but with a critical difference. This was not simply a case of orders drying up after a war ended. It was the sudden mid-program termination of a project the company had built its near-term future around, arriving at the exact moment the Cold War-era demand that had sustained Electric Boat for nearly 4 decades was itself disappearing. The company that had built the world's first nuclear submarine, that had anchored American undersea deterrence through the most dangerous decades of the Cold War, now faced a 1990s defense drawdown with no obvious successor program to replace the demand it was losing. The pattern that had defined Electric Boat since 1918, boom, collapse, uncertain rescue, was about to repeat itself for a third time. And this time, no world war was coming to save it. The years following the Seawolf cancellation brought Electric Boat closer to genuine collapse than at any point since the interwar years. With the Cold War over and the Soviet threat that had justified decades of submarine construction gone, defense budgets across the board contracted sharply through the 1990s, and submarine programs, among the most expensive line items in Navy shipbuilding, absorbed a disproportionate share of the cuts. Electric Boat's workforce, which had numbered in the tens of thousands during the peak Cold War years, was reduced dramatically as the Seawolf program wound down to its truncated 3-boat total. The specialized engineering and construction workforce that had built Nautilus, the Polaris boats, and the Los Angeles class now faced the same structural problem that had nearly ended the company in the 1920s, a set of skills with no application outside submarine construction, at a moment when submarine construction itself had almost no orders to offer. The threat this time extended beyond Electric Boat alone. By the 1990s, the American submarine construction industrial base had already narrowed to essentially 2 shipyards capable of building nuclear submarines: Electric Boat in Groton, Connecticut, and Newport News Shipbuilding in Virginia. Navy planners and members of Congress increasingly recognized that a purely competitive relationship between the 2 yards, fighting over a shrinking pool of contracts, risked destroying one of them entirely, and with it, a meaningful share of the nation's total capacity to build submarines at all. That recognition produced an unusual response. Rather than allow competition between the 2 remaining yards to determine which one might not survive the decade, the Navy began moving toward a model that treated submarine construction as a national industrial capacity to be preserved deliberately, not simply a contract to be awarded to the lowest bidder. The details of that arrangement would take shape over the following years, but the underlying logic was unmistakable. The United States could not afford to let market forces alone decide whether Electric Boat continued to exist. Electric Boat, once again, found itself dependent for its survival not on steady commercial demand, but on a deliberate decision by the U.S. government to keep an essential but financially precarious capability alive. The company had escaped extinction twice before through the arrival of a war. This time, it would need something else, an entirely new submarine program, built on a model designed explicitly to prevent the boom-bust cycle from claiming Electric Boat for good. The program that emerged to replace Seawolf was the Virginia class, and it was designed from the outset to solve a problem the Navy had watched play out 3 times across the 20th century. What happens to America's submarine building capacity when demand collapses, rather than concentrate construction at a single yard, and risk repeating the winner-take-all dynamic that had nearly destroyed Electric Boat during the Seawolf drawdown? The Navy structured the Virginia-class program around a formal teaming arrangement between Electric Boat and Newport News Shipbuilding. Instead of competing against each other for a shrinking submarine budget, the 2 yards would divide construction of each boat, with final assembly alternating between Groton and Newport News. Both yards would build hull sections. Both would receive steady work, and neither would be forced to survive on being the sole winner of an all-or-nothing contract competition. The first Virginia-class submarine, USS Virginia, was commissioned in October 2004, and the program that followed did something none of Electric Boat's prior rescues had managed. It delivered a sustained, multi-decade production run rather than a temporary wartime surge. Orders continued steadily through the 2000s and 2010s, eventually incorporating the Virginia payload module to expand the submarine's missile capacity. And the program became the centerpiece of a long-term plan to replace the aging Los Angeles-class fleet one boat at a time, year after year, rather than in a single, unpredictable burst. The Virginia-class model represented something genuinely new in Electric Boat's history, demand engineered to be stable by design, rather than demand that arrived only when a war made it unavoidable. The teaming arrangement with Newport News did not eliminate the underlying vulnerability. Both yards remained dependent on continued congressional funding, and cost and schedule pressures did not disappear entirely from either program, but it addressed, deliberately and for the first time, the exact failure mode that had brought Electric Boat to the edge of collapse in 1921 and the 1930s, and again after 1991. By the 2020s, Electric Boat was once again running near capacity, its workforce rebuilt and its order book extending years into the future. Driven now by Virginia-class production and by its role in the Columbia-class ballistic missile submarine program intended to replace the Ohio-class fleet, the company that had spent a century oscillating between wartime abundance and peacetime near extinction now operated inside a program explicitly engineered to prevent that oscillation from happening again. Whether that engineering would hold, whether a peacetime funding model could truly break a 100-year pattern, remained by design an open question the Navy itself was still actively managing. Look across the full record, and the pattern is unmistakable. 1921. The 1930s. 1991. Three separate moments, generations apart, when the same company came within reach of disappearing entirely. Not because it built bad submarines, but because the demand for good ones kept vanishing the moment a war ended or a threat receded. Each time, survival depended on something outside Electric Boat's own control. A World War in 1917, a Second World War in 1941, and finally, after the Cold War, a deliberate government decision to structure an entire production program around keeping the company alive. The Virginia-class teaming arrangement was not simply smart industrial policy. It was an admission, quiet, but unmistakable, that the free market alone had already tried and failed, twice, to keep America's most important submarine builder in business. That admission points to something larger than one company's balance sheet. By the 2020s, the United States had exactly two shipyards capable of building nuclear submarines. Electric Boat and Newport News, not 20, not 10, two. A century of boom and bust procurement had not just strained Electric Boat. It had quietly narrowed an entire national capability down to a number with almost no margin for error. Lose one of those 2 yards, and the country does not have a competitor ready to fill the gap. It has a crisis. The Navy understands this. It is why the Virginia-class program exists in its current form, why the Columbia-class was structured the way it was, and why officials at the Pentagon now speak openly about submarine construction capacity as a strategic vulnerability requiring active, ongoing management, not a market to be left alone and trusted to sort itself out. Electric Boat is still standing. It built almost every submarine the United States Navy has ever put to sea, and it is still building them today, but that continuity was never guaranteed by the company's skill alone. It survived 3 near collapses because, each time, something arrived just in time to save it. The record does not show a company that solved the problem of building submarines in peacetime. It shows a country that has spent 100 years hoping it never has to find out what happens if the rescue doesn't come next time.